Hello everyone, welcome to Microsoft Data and AI South Florida user group. Today we have Haripriya Naidu here with us today to discuss on the TempDB contention topic. I know many of you are looking forward for this presentation. A lot of you are really waiting for it. I am also waiting for it too because I wanted to learn from Haripriya today. So if you are online and wherever you are joining from, say hi into the YouTube chat, and I'll be monitoring any questions you have. And welcome, Haripriya. We are so honored to have you here, and thank you so much for speaking to our user group. Please go ahead and take it over.
Thanks, Deepthi. Hello, everyone. Let me go ahead and first share my screen. All right. So today's topic is TempDB contention, and we will see how to identify and resolve it. This is one of those performance issues like I've learned the hard way in my earlier years as a database administrator, and that's the reason I chose to talk about it, so I can probably help you all with giving you the right tools to handle this smoothly if this were to occur on your production servers. All right. And about myself, I've been working as a SQL database administrator for a bit more than 10 years now. I'm very passionate about databases. I love engine internals and tuning performance. It has always been intriguing for me. And I'm an AWS certified solutions architect. I work a lot on EC2 instances with SQL Server installed on it, so that helps a lot. And I won an award at work that's called Rookie of the Year last year. And on the personal end, I have two kids and my husband. I usually say so that equals three kids. So that's about me. So today's agenda, I will be discussing about what are the different types of TempDB contention and how do we identify it, and also the different ways to resolve it. This will not be a very basic stuff. It will be on the intermediate level. So if you do have any questions, feel free to post them in the chat and I can address them. And I will be making pauses in between and address the questions as well. All right. So what is the need to learn about TempDB contention? First thing, you want to address the slowness on your system. So when there is a slowness on the system, and if that's caused by TempDB, you want to know how to address it. To find out and to resolve that slowness, you need to understand what this TempDB contention is all about. And speaking about concurrency management, you take any production server at any given point of time, you have hundreds of thousands of concurrent transactions running. And how do you manage them all without causing contention? It is important to understand how contention first occurs, and then you can resolve all of that. At the end of the session, you will see that we would have addressed both the slowness and the concurrent transactions, how to manage them. So why is there contention on TempDB, or why are we talking about TempDB? If you take any SQL Server instance, you have multiple user databases in them, and any connections pertaining to that user database will just run on them. Like you're running inserts, updates, and deletes on a user table, will just run on that user database. But if you take TempDB, any user connection that has temp table operations or table variables or sorting, hashing, online index operations, or if you use read committed snapshot isolation level, any of those things will use TempDB coming from any database. And there is only one TempDB in that whole SQL Server instance. So the workload is either 10 times more or even 100 times more, because it has to take all of that load from all the user databases when you have this temp table or any operations that involves TempDB. And no wonder there is contention on TempDB. And that's the reason we are going to be talking about TempDB contention today. We will be discussing two types of contention in detail. I will be showing the demo as well for each of these. First one is the object allocation contention, that's of the DML type, and second one is the DDL type, which is metadata contention. First one, object allocation contention. So when you have inserts, updates, or deletes running on any temporary objects, they always need to get a latch onto these three special pages called PFS, GAM, and SGAM pages. Because those three pages will give you the free space information and the allocation information, but I'm not going to go into the internal details today. I just want to mention that it needs to get a latch on these three pages. All right. So all these DML operations, when they run, the point here is they need to get a latch on these three pages. Under normal circumstances, you just have a few operations running. They can easily get a latch. But when you have too many operations, for example, in very busy OLTP systems, there will be too many of these inserts, updates, and deletes constantly running on your stored procedures. Then what happens is now all these operations are waiting in line to get the latch onto these three pages. And that causes contention. All right, so DML operations waiting to get a latch on PFS, GAM, SGAM pages causing contention is called allocation contention. And by the way, latch means a lightweight lock. If you look at this data file, let's call it tempdb.mdf, multiple transactions are hitting on that data file, trying to get a latch onto PFS, GAM, and SGAM. And that causes contention. And in a data file, you have multiple sets of PFS, GAM, and SGAM pages based on the size of the data file. And if you're interested to know why it repeats every 8088 pages, or why GAM and SGAM repeats every 511,232 pages, I've written a blog post about it, and you can check out the blog. Like I said, dealing about the internals and things like that, it's not in the scope of today's presentation. So I just wanted to leave it at that place. All you need to know is when you have too many transactions hitting on the data file, they cause contention on PFS, GAM, SGAM pages. Okay, how do you identify this when there is contention? How do you know, oh, there is contention on the server? How do you know that? I will show you the script in the demo when I run it, but the result set will look something like this. You will see the wait type page latch, and you will see it on GAM page or SGAM page or PFS page. If you see page latches on just three of these pages, then it is allocation contention. And one more important thing is page latch is different from page IO latch. Page latch means trying to get the latch on the page. That's page latch. And that is what we are interested in today's session, because that's all about TempDB contention. Page IO latch is about bringing pages from storage to memory. And we're not going to talk about it today. That's a whole different topic by itself. All right. So, and let's also decode this wait resource. The first number is the database ID. 2 is always for TempDB. And the second number is the data file number, like the 4th file ID or the 5th file ID. Don't worry about it. And the third number is the page number. You don't have to remember what page number is what special page, because in 2019 SQL Server version, we have 2 new functions that will tell you if it's PFS, GAM, or SGAM without much calculation. So all you have to know is if you see page latches on database ID 2, which is TempDB, and on pages PFS, GAM, or SGAM, then you know it is allocation contention. Okay, now that you know how to identify it, how do we resolve it? Bringing this image back where you have a data file and transactions are hitting on them, trying to get a latch, and you have contention on PFS, GAM, and SGAM pages. How do we reduce this contention? When you have more PFS, GAM, SGAM pages, then the transactions can spread across, right? How do we get more PFS, GAM, and SGAM pages? By creating more data files. So let me go ahead and create 4 data files. What happens? You get 4 new sets of PFS, GAM, and SGAM pages. Now the transactions, they are spread across multiple data files. Now contention reduces. In some cases it reduces, in some cases it gets resolved. So you can't be sure about it will completely resolve it, but you will be able to mitigate it to a good extent by adding more data files. All right. And also in 2017, they also made another enhancement with PFS page where the transactions will round robin across the data file and also within the data file. If you see this here, allocation 1 on first data file, 2 on the second data file, 3, 4, and then 5 comes back down here. So it goes 1, 2, 3, 4, and then 5, 6, 7, and 8. So this is how the allocations round robin across the data files and also within the data files. And that's how this allocation contention produces. And only when you see this page latches on PFS GAM SGAM pages, you're adding the data files. If you see the page latch on any other pages, adding data files will not help. So that's why I kept saying, if you see page latches on PFS GAM SGAM, then you add the data files. All right. So this is the one that we just saw, round robin across data files and PFS pages. That will help mitigate contention. And how many data files do we add? You add 4 or 8 data files. For example, start with 4 data files, check for contention. If it reduces, good. And reduces a little bit, try adding another 4 and again check for contention. Imagine if you have, something like 90 plus processors, it's a huge machine on your production, then go with 8 data files because 4 and increasing by 4 might take a long time. So when you start adding it, you'll get the hang of it. So then you can go with 8, check for contention, add another 8. When you add those data files, you add them with the same size. You create those files with the same size as the existing file size. Imagine you're already the TempDB data files that you already have. If they are 2 gig each, then the new files that you create should also be 2 gig each. The reason being, we want those transactions to round robin across the data files. If you create them with equal size, that means you have the files with same free space. Then the transactions will round robin across the files. If you create them with unequal sizes, that means one file is bigger than the other file. That also means one file has more free space than the other files. Then all those transactions will start hitting on that big file, which has a lot of free space. And that will create a hotspot, which is exactly what we don't want. That is why always create data files with equal sizes. All right. And if you happen to do this during a maintenance window or over the weekends, downtime, go ahead and restart the SQL service. The reason being, because this is TempDB, when you restart the service, TempDB data files that are already there will get restarted from scratch, which means the data files which already had data in it, or those operations, everything will be scratched out. It will start from 0. So it will have completely, for example, I'll make it simple. So if you have 2 gig of those existing data files, and then you added another 2 gig of 4 files, right? So the old files that are there and the new files that you just added, now all of them will have equal free space because this is TempDB. It gets started from scratch. So that's the reason there is a recommendation to restart the SQL service if possible, when you add the new data files. If you're in the middle of a business day and if you can't do it, that's still fine too. You don't have to, but if you have the opportunity, go ahead and restart the SQL service. All right. So the key point you have to remember to resolve this allocation contention is when you see page latches on PFS GAM SGAM pages, add 4 or 8 data files with equal sizes, check for contention, and again add another 4 or 8 data files. All right. If you look at version wise, before 2016, for example, in 2014 and 2012, trace flags 1117 and 1118 were extremely helpful. For I think the mixed extent allocations, those 2 flags were addressing a good number of things. So they were extremely helpful, and the recommendation was to turn them on. But from 2016 version and onwards, you don't have to turn them on because they are turned on by default with the engine itself. So you don't have to turn them on. And we know that I've seen that many servers, even nowadays, even on 22, these 2 trace flags are turned on. Well, you don't have to do it. you can go ahead and remove it because it's already on with the install itself. And there was a very good improvement in 2019. You remember I just told you page latches, they are waiting in line to get a latch onto PFS page, right? So the improvement that they did in 2019 is now all those operations, they are not waiting in line to get that page latch onto the PFS page. They have been updated to shared latches. Now all these operations, they can share the latch onto PFS page. So if you check 2019, you will still have TempDB contention, but not on PFS page. You will only see GAM and SGAM page in your result set. So, and that helped a lot. You know, with 2019 version, there's no PFS page contention, but you will still see GAM and SGAM page because on PFS page, they updated the latches to shared latches. They can all share the latches, the operations. And they did the same concept in 22 version. Those exclusive latches, they can all now share the latches, all those operations. For GAM and SGAM page also, they can share the latches. Those operations don't have to wait in line anymore, waiting for the page latch, they can all share the latches. And there was a very good enhancement which helped resolve TempDB contention on 22. All right, so this allocation contention, you know, it's all about contention on PFS, GAM, SGAM. So on 22, now that is all resolved because you're not seeing those page latches on PFS, GAM, SGAM because they are resolved by default. You don't have to take any action manually. They just come with the engine. They are resolved by default. You will not see this type of contention on 22. This allocation contention does not exist on 22. You don't have to add any more data files. All right, so whatever comes with the install, if you have 4 processors, you're going to get 4 data files. If you have 8 or more processors, you will get 8 data files for TempDB. And that's enough. You don't have to do anything if you're on 22 version. All right, that being said, you still follow all the best practices across all versions, even on 22. So the thing here is, I'm migrating to 22 from 2017 or 2016. You just bring over all the TempDB data files that you have. You can go ahead and bring everything over. And if you want, you can, I think, remove them off. But what we have done is, and what I heard is like, just bring everything over and, just go ahead with it. Don't remove anything. Don't remove any of the data files. But when you start from scratch, like you are building a brand new server on 22 for a new application or something, you can just leave it at 4 or 8 data files. You don't have to add any more data files and it should be totally fine. All right. So to summarize, we took a look at first type of contention, that is allocation contention. You will see page latches on PFS, GAM, SGAM pages, just these 3 pages. Then it is called allocation contention. Instead of PFS, GAM, SGAM, if you see system objects or data pages, no, that is not called allocation contention. That is very important to understand. So once you see page latches on PFS, GAM, SGAM, then you know it is called allocation contention. Then you go ahead and add data files in numbers of 4 or 8 with equal sizes. All right. So this brings us to the end of first type. Any questions? All good? All right. All right. All good then. I will go over with the second type of contention. All right. This is metadata contention. Earlier we saw the DML type. This is DDL type. So when you do create temp table or drop temp table, these operations, they always need a latch onto the system object pages. When you have too many create temp table, drop temp table, then there occurs contention. And this contention is on the system object pages. So that's the key difference between allocation contention and metadata contention. The first type that you saw, it's page latches on PFS, GAM, SGAM. This one, it's page latches on system object pages. So, for example, this is an image. If you look at this, you see how there are multiple operations trying to acquire a latch onto one of the system objects, causing contention, right? In this picture, there's just one system object shown, but there are actually 12 system objects that these DDL operations may need access to. So when you have this contention, how do you identify it? It's the same concept. You will see page latch, but this time you will see it on the system objects like sys allocation units or sys schema objects or anything that starts with sys. You should not, I mean, if you see PFS GAM as GAM, this is not metadata contention. So you have to understand that key difference. You see page latches on PFS GAM as GAM, it's allocation contention. If you see page latches on system objects, then it is metadata contention. And how do we resolve this? So the point here is, I know we are all tempted to clean up our temporary tables at the end of stored procedures, but you don't have to do it. Do not explicitly drop or truncate your temporary tables at the end of the stored procedure, because SQL Server will drop them asynchronously, and that is based out of optimistic latching algorithm. So you don't have to drop it. When you're done with your session, SQL Server will asynchronously drop them based on the number of concurrent alter drop operations that are actually running on the server. So it will do the job. It will do the cleanup job for you. You don't have to do it, because when you drop the temp table, it is again waiting for a latch onto the system objects. To prevent or to avoid those page latches onto the system objects, the recommendation is to not drop your temporary tables. SQL Server will drop them for you. And the second thing is, cache your temporary objects. How do we cache the temporary objects? There are a few key rules for this. And the first one is, do not alter your temporary table. So if you create your temporary table, do not create an index outside of the table definition. Right? Create index. You see how the create table parenthesis definition is, and then you're creating it outside. Because once you create it outside the definition, it means you're altering the temporary table TDL. And that also means it will not be able to cache that temp table. Instead, what you could do is create that index in line with the definition. So when you create the table and you open the parenthesis, list out the columns, create your constraints or create your indexes, do everything just inside the table definition, and then close the parenthesis, which means you're creating it inside the table definition. That will help you cache the temp table. And the third rule is, whenever you create a temp table, do not send it as an ad hoc session. Wrap it up inside a stored procedure or a function or a trigger. So these three rules will help you. Well, there are so many others too, but these three are kind of important ones that we, see it on a daily basis in our stored procedures. Do not create the indexes outside of the table definition. Create them in line with the table definition and wrap them up inside the stored procedure. This will help you cache the temporary tables. And also, do not drop your temporary tables at the end of the session. So doing these will help reduce metadata contention, but you will still see some metadata contention. For that, what we can do is, we can turn on the in-memory TempDB metadata feature. This is a new feature starting in SQL 2019. So what this feature does is, it will move all the heavily utilized system objects to memory, making it latch-free. It will not move any user objects or anything else, just 12 system objects to memory. So it can be latch-free and lock-free. And this feature is off by default. If you need it, you have to turn it on. And you turn it on using this configuration, server configuration, set memory optimized, TempDB metadata on. You could also use the resource pool if you like. And these are the 12 system objects that will actually be moved to memory. And if you're on 2019, make sure you're on the latest version. It is also available on 22, of course. All right. Any questions? This is the end of the second type of contention. Any questions before we move into the demo? All good? All right. Let's head into the demo. You can see my screen, right? Okay, that's good. So what I'm going to do now in the demo is cost contention on both 2019 and 22, and I will show you how to resolve and how to first identify and then how to resolve contention on 19, and also do the same thing on 22. All right. So the first thing is 22. Let's check this out. Okay, no, I can't. Sorry, just give me a second. No, I can't hear you, Deepthi, if you're talking. Do you want me to pause? Okay, all right. Yeah, I see you popping in now. All right. I mean, if you want to talk, just stop me.
There are no questions,
No
Haripriya.
questions,
Thank you.
Haripriya. Yeah, please go ahead.
Okay. Thank you. Yeah, I couldn't hear anything earlier. All right, thanks. All right, so I'm on 2019 now. So let me go check the version for you. So it's 2019, it's U27, and how many processors we have? 14. And I have 8 TempDB data files that came with the install. I haven't added anything new. All right, and what I'm going to do now is I borrowed this simple stored procedure from Klaus Askenbrenner because I got the idea from him. Excuse me. So I'm going to use this DBA test database, create this stored procedure called populate temp table. It just has a temp table inside of it with 3 columns, and we'll insert 10 records. Okay. So let me go ahead and do this. Created the stored procedure. And so I'm going to cause contention by using this OStress utility tool, which is a free Microsoft command line tool that you can actually use it to, stress test your server, so you can troubleshoot the issues that come out of it. It's just a free tool, and you can download it. I've also tagged this link on the in the resources tab if you want to get it. All right, and this is the OStress executable server name, and execute this stored procedure. N50 means run on 50 concurrent threads. R1000 is run the query 1000 times. All right, so it will run on 50 concurrent threads for 1000 times. And before I kick this off, I want to show you the contention script that I'm going to be using. So what the script does is it collects the information from the DM base. So DM exec request, this will give you the currently active request, and DM exec SQL text, when used in conjunction with this DM exec request and SQL handle is passed, you get the text out of it, like what is that text for the currently active request. And these two functions, fn page cracker and DMDB page info, these two new functions, they were introduced in 2019. So when they both are used together, it gives a lot of information about page details. It will give you, especially when you want to troubleshoot page related weights, these two functions gives you a bunch of information. All right, and I'm filtering this by weight type page latch because, like I said, in this session we are only interested in page latch. All right, let me go ahead and run this. You shouldn't see anything now because we haven't kicked off anything yet. Now I'm going to go run this stress test on the command line. Let's see. Okay, so creating 50 threads, worker threads created. Let's go check for contention. What do we see now? All right, so we see page latch on system object. So you know that page latch on system object is metadata contention, because system object is nothing but metadata object. So that's why it's called metadata contention. I'm going to scroll all the way to the end I can see the allocation type. I'm going to scroll all the way to the end here too, and I see the allocation type. All right. Okay, so all we have is metadata contention. And how do we resolve this metadata contention? What we have to first check is check our stored procedure, how it looks. Are we able to cache it? For example, the few rules that we discussed. We are not dropping our temp table at the end of the stored procedure. So that's good. And we are creating the primary key within the table definition. So that's again good. And we are wrapping this temp table inside the stored procedure. That is good too. So these are the few things that I want you to check whenever you see metadata contention. Even after doing these things, you will still have some metadata contention, which you can resolve by using this new feature that I just talked about, which is the memory optimized TempDB metadata. So it is off by default. So if I check here, this is 0. I'm going to go turn it on using the server configuration. And for this to take effect, I need to restart my SQL service. And I'm just doing it from SSMS. Don't do it like me. It's just sandbox, so I'm just doing it here. When you do it, please do it from your configuration manager for standalone instances or the cluster manager for the clustered instances. And when you enable this configuration, make sure you are doing it both on your active or passive nodes or both the primary and secondary nodes. So when you do the failover, it is consistent. All right, now I turned it on. So let me go ahead and check it. The value is 1, which means it's enabled. And I want to show you what are the objects that moved to memory. We should see 12 objects. That's good. Also, I want to show you this thing. The contention that we had was on this, right? Sys allocation units or sys RS calls. You will see now these two tables in here. Sys allocation units, sys RS calls. I don't see. Okay, I see it here. Okay, so you see it here. So these objects now have been moved to memory. So the next time when I run the workload, we shouldn't see these page latches on these objects because they have been moved to a different part in memory, which is latch free. All right, so that's the whole point of moving these objects to memory. That way you won't see this contention. And now that we moved these to memory, how much memory is it actually occupying? It's just 81 meg. That's absolutely nothing. So we are good. All right. So the only change that I did is turned on in-memory TempDB metadata feature. So what I'm going to do now is run the same workload again, exactly the same workload that we just ran. So I'm going to run the same workload again and check for contention. All right, what do I see now? I see page latches, but I don't see system objects anymore. So that's good. And I'm going to scroll all the way to the end. Oh, good. There's no system objects. So it looks like we got rid of metadata contention. At the same time, I also want you to notice that we are seeing page latches on GAM page. So if you see on PFS, GAM, or SGAM, then it is allocation contention, right? I'm going to scroll all the way to the end. You see allocation contention, and then all the way to the end, allocation contention. So all we see is allocation contention. One good thing, we got rid of metadata contention. And the second thing is, now we see allocation contention. How do we resolve this? This is because of contention on PFS, GAM, SGAM pages. So we are going to add 4 data files because we will get more PFS, GAM, SGAM pages. When you add 4 data files, let's check if this contention is getting reduced. Before adding any of these data files, what I want to do is turn on perfmon, which is 2019, yes. Turn on the perfmon, and I want to get a graph or the spike of the contention right now. And then I'm going to add another 4 data files and check the graph again. That's when I will exactly know how much contention or how many page latches have actually reduced from adding the data files. All right. So I'm not going to take any action right now. Just I'll be running this perfmon, kick off the workload, and grab the spikes. So the green line is the throughput, the workload that we are running, and red line is the page latches. If you see page latches here, so we are at a maximum of 15,000. If you see this number here, so we have 15,000 page latches for the 8 data files that we actually have, which came with the install. Looks like this is finished. So this will also drop down soon. All right, so this is good. So now with the 8 data files that came with the install, we checked how the spike of page latches looks like, right? So I'm going to go ahead and add 4 data files. We have 8, that's good, which came with the install. Now I'm going to add 4 data files, all right? What I'm going to do now is kick off this one and start the workload. Let's see how it is now. Okay, the throughput has gone up because we are running the workload. Now where is the spike? It is at 6,800 right now. Okay, it's going a bit down. You see the difference now? We came down anywhere from 15,000, maximum of 15,000 to close to 7,000. So that's a reduction of more than 50%, like 50% of page latches we have been able to reduce because of adding 4 data files. So that's the reason I brought up perf1, is because without perf1, if I just add the data files, I will know that contention has gone down, but how much? I need the numbers, right? How much has it gone down? Was that a significant impact, or just a little bit, or should I add more? For all those questions, you'll get that informed. You can make that informed decision. So now that it's reduced like 50%, I want to go ahead and try adding another set of 4 data files and see if it's going even more down. All right. Let me go ahead now. I should have 12 because I added 4. Now I'm going to add another 4. Okay. Now I will kick off this Pokemon and then start the workload and see how it behaves. So now we have added 4 data files. Let's see if it goes even down. All right. Okay. It's at 5,000. Okay. It went back up. 6,000. Okay. So if you see, we have not made any difference right now by adding that another 4 data files, right? Clearly, we didn't make a difference. So I'm going to stop at this point because I was not able to reduce any more page latches. So let me stop right here. If you just were to do it from SSMS, you're like, oh, did any page latches go down or not? You'll have that confusion. But from this, you can tell, yes, the first set of 4 data files, you were able to make a difference. You reduced the page latches. With the second set, nothing reduced. So I'm not going to go ahead and add any more data files. I'll just stop at this point. Okay. And like I said, in 2019 or lower versions, you will be able to mitigate it to some extent. Not in all the cases, you will be able to completely resolve this allocation contention. All right. So what we saw now, 2019 version, allocation contention, we added 4 data files, reduced 50% of page latch contention. We tried adding another 4 data files, absolutely no reduction. So we are stopping at this point. For metadata contention, we enabled that in-memory TempDB metadata feature, and that resolved the metadata contention for us. All right, so this is about 2019. I'm going to do the exact same thing on 22. The only difference is the version. All right, so check the version, 22, 14 processors, and I have 8 TempDB data files, exactly the same stored procedure that I just created. All right, and so here's the contention script I have. I'll execute it on 22. You shouldn't see anything because I haven't kicked off the workload yet. Now what I'm going to do is go run this thing. It's the same script. It's just the 22 version is different, okay? So I'll go run this here. It's on 22 version. Kick off the workload. Check for contention now. What do I see? Page latches on system objects, which is nothing but metadata objects. That means you have metadata contention, and I'm scrolling all the way to the end. It's metadata contention, and we know how to resolve this because our stored procedure already looks good. All we have to do is turn on this in-memory TempDB metadata feature. It's 0 because it comes disabled by default. I'm going to turn it on, and this needs a restart of the service because that's when the hackathon DLLs get configured with the restart. All right, it's actually in this window. Let me bring it up here. All right, so we restarted it now. Let me check. It's 1. That's good. It's enabled. And if you see, we should have 12 tables. That's perfect. And let's check the memory. It's occupying 80 meg. That's nothing. All right, so that's good. So we have, this is 22 version. We saw metadata contention. So I enabled that in-memory TempDB metadata feature. I'm going to go ahead and kick off that same workload again and see how contention is. Wow, nice. That's absolutely nothing. So this is 22 version and we didn't see any contention at all, right? It's still running, but I still don't see any contention. I don't see anything. Okay, I know we resolved metadata contention. How about allocation contention? We didn't add any data files and I don't see anything at all. Well, I'm not going to trust SSMS completely, though I'm a fan of SSMS and SQL Server, but I'm going to go ahead and turn on Perfmon to see if we are missing any page latches on SSMS. You know, by the time you press F5, you might miss a few. So let's go check on Perfmon if we are able to capture any page latches. All right. So I have 22 version, 2022 version SQL Server here configured for the Perfmon counters. I'm going to go ahead and start this and kick off the workload. Let's see if you're able to see anything. Okay, the throughput is higher because the workload is running. But how about the red line, which is the page latch? It's just a flat 0. You see all the numbers here, everything is 0. Absolutely no page latches. And we didn't even add any data files. Absolutely no page latches. So that's the beauty of 2022 version. You will not see page latches for PFS, GAM, or SCAM pages. You don't have to add the data files. It is resolved by default within the engine. You don't have to add the data files. Allocation contention does not exist on 22 version. But you have to remember that metadata contention still exists on 22 and you have to manually resolve it. Metadata contention is nothing but the one we just did. In-memory TempDB metadata feature. If you see page latches on system objects, you enable this feature. Well, you take care of caching your temporary objects and stop dropping those temporary objects. And then if you still see, then you enable this new feature. All right. So now we saw 22. And on this 22 version, what we saw was just metadata contention, and we enabled this new feature. We did not see allocation contention at all. We didn't add any data files because the contention on PFS, GAM, and SCAM pages are resolved within the engine itself. All right. So that's the demo all about. Any questions? Okay, I see something. Aside from the primary key cluster index, a common practice is to create the table, then insert data, and then add other indexes after for better performance. Okay, Jim, I think it really depends upon the environment and the workload you have. For example, if you just have a staging temp table, if that's not too big, and you have that stored procedure which has this temp table running concurrently for many number of times on your server, then it is a good idea to cache that temp table so you can reduce the number of page latches. The only reason I say to create the index within the temp table is if you want to cache the temp table or if you're experiencing server level performance issues. Now, this is the trade-off. Do you want query level performance or the server level performance? If you're taking a hit on server level performance, if you're seeing a lot of page latches, then letting the query run for a few more seconds is totally fine because you're seeing page latches causing contention on the server. But if in your case, you're not seeing any page latches and you're totally fine with your server level performance, all you want is your query to run faster, then it's totally fine to create the index later. It only depends upon what you need for the environment. If your issue is with the page latch, then go ahead and index it first so it can cache that temp table. I hope that answered your question, Jim. Is this a good practice considering what you said earlier? Yes, like I said, it's what is the problem you want to resolve. Here I'm resolving page latch contention. So if you have page latches on your server level, go ahead and first create the index so the table can get cached. But if you're not seeing page latches, if you have monitoring tool or just a regular performance, you just don't see any page latches with your execution of stored procedures, then don't worry about caching the temp table. That's fine. Just focus on the query level performance. Yeah, yeah. So it really depends upon what we need. All right. Anything else? Any more questions? All right. I will just jump back to the slide deck. Just a couple more minutes. Okay, so now that our demo is done, what I want to show you is the common mistakes that we all make, including myself. First thing, the moment you hear about TempDB contention, people are just so eager to go add the data files. Please do not do that. When you see page latch on PFS GAM SGAM, I know I repeated it a million times. When you see page latches on PFS GAM SGAM, only then you create the data files because you get more sets of PFS GAM SGAM pages. If you see page latches on system objects, do not create data files. That is not going to help. It is very important you understand that, okay? So it's not always about data files on TempDB. I've made that mistake too. That is why I'm emphasizing it so much here. And there is a misconception online. If you see, check out the websites like Stack Overflow or things like that, people are like, oh, I'm on 22. Why am I still seeing contention? Of course, you will still see contention because only the allocation contention part is resolved by default, which is you don't have to add the data files on 22. The metadata contention still exists. The one I just showed you, maybe you have to cache your temp tables or you have to turn on the in-memory TempDB metadata feature. That's all metadata contention. That still exists on 22 and you have to manually resolve it. That is not resolved by default. So you will still see metadata contention even on 22 and please go ahead and resolve it manually. And the third thing is, it's not like a mistake, more like a caution. So this feature, the new feature that I just talked about, if you want to use it on 2019, please be very cautious. It is a little buggy on 2019 because it is causing unexpected server restarts. So I would be very cautious turning this on 2019. And if you are encountering issues after you turn it on 2019, check out the link that I just pasted and it gives you, a bunch of things to do. But I kind of discourage you from turning this feature on 2019, but it works better on 22. I do recommend you that you can turn this feature on 22. It does work fine on 22, but like any other, memory stuff, if you have long running sleeping transaction, not running, I should say, probably open transaction, that has been open for a long time, idle transaction. So that will hold up the memory cleanup for the remaining transactions. So that will cause the in-memory TempDB to blow out. So you have to be careful about if there are any open long-running transactions, which are basically sleeping and holds up the memory cleanup. Not only for this feature, even for version store cleanup, it does hold up the memory cleanup. So the point I'm trying to tell here is, you can turn this on 22, but on 2019, if you want to turn it on, please do rigorous testing. All right. I know I have said a bunch of things, and before that, you have any question? One more, please. I use user-defined table types as parameters into procedures with and without memory optimized on. So that is totally different from this. Okay, so Jim's question is, he's asking about for the user-defined table types. That does not apply to the TempDB part that we are discussing here. Or you're asking, do these use TempDB? No, they don't use TempDB as long as you don't. These are user-defined table types, right? So they are going to be only using the in-memory OLTP structure within your user databases. The moment you do hash, temp table, and things like that, that's going to use TempDB. All right. So, and if you're creating, altering temp table, that will use TempDB and the metadata. Just using memory optimized will not use TempDB. And is it a good idea to use a user-defined table type as a temp table within a procedure instead of temp table? Okay, I don't think I'm going to make any conclusion in that one. I'm always a fan of temp table. So I'm going to be doing temp tables, but it does depend on, based on the type of work that you're doing. If you want to do user-defined table types, if you're used to it, go ahead and do it. Or if there are any advantages, I'm not sure about them. I've mostly used temp tables, so I'm good with that. But yeah, so I don't think I have an exact answer for your last question. All right. All right, back to our slide deck. So I know I've given a lot of information this past hour. So if you have this flowchart handy, I think this is more than enough for this whole session. So you can easily resolve or at least address contention. All right. First thing, do you see page latches? Yes. Do you see it on TempDB? This is important because I've also made the mistake, like even if I see it on other databases, I'm like, oh, TempDB contention. No, make sure you see it on TempDB database ID 2 or TempDB database. Okay, so that's very important. Only if you see these two, then go ahead with this flowchart or go ahead with the contention resolution. Do you see these page latches on PFS gamma scam page? Yes. Then add 4 data files or 8 data files of equal size. Now check contention again. You see it? Yes. Just go in the loop. Add 4 or 8 data files, check for contention, just keep checking, for contention after you add the data files. Next thing. Okay, you don't see page latches on PFS gamma scam. Instead, you see it on system objects. What do? Cache your temporary objects or do not drop your temporary objects. That will help reduce this metadata contention, which is on the system objects. Now check again for contention, and if you still see it, turn on this in-memory TempDB metadata feature in 22. So these are the 2 different directions that you have to take if you see page latches on PFS gamma scam or you see page latches on system objects. This is the important part. Only the one in green box is resolved in 22. You don't have to address it if you're on 22 version. Just don't even think about it because that's resolved. But this part below there, the metadata contention, still exists and you have to manually address it. All right. I really hope this adds value for the time you spent here, because if you have this flowchart, I think it should be good enough to resolve or to address any TempDB contention that you might have on your servers. Summary. If you see page latches on PFS gamma scam that I kept saying a million times, then you know it is allocation contention. On versions less than 22, you have to add 4 or 8 data files of equal size, and you'll be able to mitigate it to some extent. If you see it on 20, you won't see it on 22 because it's resolved by default. And the best way, I think, is to upgrade to 22. If you are facing a lot of this allocation contention, just upgrade to 22. Metadata contention. If you see page latches on system object pages, then you know it is metadata contention. Stop dropping the temporary objects, cache your temporary objects, and then finally you can also turn on the in-memory TempDB metadata feature in 22. So this you have to manually resolve in all the versions, including 22. All right. These are some good resources that you can take a look at, which talks more about this TempDB and its contention. Any questions? And I've written a lot about TempDB on my blog and also about SQL Server. So if you're interested, you can take a look. And if you have any questions, even after this session, feel free to DM me or, send me an email. And the slide deck and the scripts, everything is available on GitHub. All right.
That's an excellent session, Haripriya. Awesome. And you also answered all of the questions. I just went out of the camera, out of the screen, so I couldn't talk to you in between, but you handled it so well. Yeah, if anybody have any questions, I'm still monitoring. You can still ask. Jimmy saying thank you.
Thank you.
Thank you, Jim, for attending. Yeah.
And Haripriya, can you hang on just a second here after we conclude?
Sure. Yeah.
All right. Thank you. And final thoughts, Deepti and Haripriya?
Thanks everyone for joining. I hope this session was of value to you, and yeah, that's the reason I'm doing this, so it can be helpful for you. And thanks again, everyone, for joining.
Yeah, the same goes with me as well. Thank you so much for taking your time. Haripriya, first, thank you so much. It's an excellent session. Definitely, the audience will come back again and see the recording. I mean, if you wanted to look at the introductory session on TempDB, type in TempDB Haripriya, you'll find a lot of videos on TempDB introductory as well. So that you can first watch that and then come to this session because it's an extended version and then in another level like Haripriya mentioned, it's an additional complexity level. So with the number one part and number two part, with this part, I think you'll get most of TempDB and how to resolve the TempDB contention. And thank you so much once again, wherever you are joining from, for taking your time and learning something today about TempDB. So I wish you all a happy. It's not any
You're looking for
yeah,
some
happy New Year or like
happy
I'm
year.
I'm still in that in that phase of like a happy New Year. But I wish you all have a great evening and yeah, have a great rest of your week and weekend and yeah, thank you so much. Take care.